So here is the model that we'll be working with. We have to do two maximizations, one for the numerator and the other for the denominator. They are both very similar. So I'll first do it for the numerator alone, and there I'll be working with our general linear model x. Then later I will replace that x with x naught and get the corresponding result for the denominator. I want to find out the maximum possible value of the likelihood. The likelihood is given by this, our familiar multivariate Gaussian density without the various 2 pi's and things like that, the constants. Now we want to maximize this, which effectively means we are going to plug the maximum likelihood estimators of beta and sigma square in it. The maximum likelihood estimators are pretty straightforward. For beta hat, it is just any least square estimator. Any least square estimator, I am not assuming that x is full column rank or anything, need not be unique. We are not really caring about beta hat here, we are caring about the maximum value that you can get for the likelihood. Now we have to maximize with respect to sigma square hat. So once I have that sigma square hat, that will turn out to be the residual sum of square. It is y minus x beta hat. The hat is not clearly visible here, so it is the residual sum of square divided by n, not by n minus rank of x, so it need not be unbiased. Once I plug these two inside my likelihood, I will get the maximum possible value of the likelihood, unrestricted maximum likelihood. You can see some massive cancellation is going to happen here, because once you put sigma square hat equal to that, this will just cancel off this term and you will be left with something which is free of parameter as well as data inside the exponential. So it will be a constant to be absorbed inside the proportionality. So the only thing that's going to survive will be the sigma square hat, and that is already the RSS. So it is going to be, the maximum value is going to be some fixed constant, does not depend on data, does not depend on parameter, doesn't depend on anything. It only depends on n, RSS to the power minus n by 2. So whatever I can say about the general model may be said about the null model also, except that x will be replaced by x naught. So under null, same thing, but we will be working with RSS naught. Now we shall give the likelihood ratio. The likelihood ratio test will work with this thing. Things will cancel out, whatever remains, that's just an absolute constant, and you are left with RSS naught by RSS to the power n by 2. Just observe that I have h naught in the denominator. RSS naught has gone to the numerator because I have made this n by 2 and not minus n by 2. So things have flipped. So likelihood ratio test will reject if this quantity, this RSS naught by RSS is large, which equivalently means RSS naught minus RSS divided by RSS is large. You just subtract 1 from it, and this is our familiar intuitive form, the extra residual sum of square divided by the acceptable residual sum of square. So this little argument shows that LRT is indeed the same test as our intuitive test.